Let me welcome every one of you. Welcome to the new upcoming fundamental training. My name is Christian, and the most important information directly at the beginning. So this training will be recorded, and you will get access and notified by email when it's available, and then you will be able to download it. It usually takes us, let's say something between 3 or 5 days to cut it a little bit and to upload it and so on. So but you will get it, and that's the most important thing. About a short introduction about myself, I think Marcus will also introduce itself. My name is Christian Kuemmel. I'm senior Java developer, project manager, and also trainer, conference speaker. I'm involved in a lot of different projects, and I'm also the project manager of the EclipseStore Data Grid cluster development. And as you see, also in a lot of different projects involved, especially where EclipseStore as a technology is used, and that is on the Allianz insurance company, and also at Fraport, German Frankfurt Airport. Let's move on. So let's go through the topic a little bit of today. First, we start at 5, so I think we are good in time. It takes us till 9, around 5 lessons, I have to say, with a little break in between. At the break, it could differ a little bit. Usually we have that break something around at 7 or so, the Central European time, 7. And we will see. Some further informations before we get into the topics. The material of the training itself, so that means all the GitHub repositories and so on. Every project that we work on, that training will be available within GitHub. And before I jump into a topic, I will always share the repository with you that enables you to code along with me if you want. And I will go step by step through the different projects, and after that you will have your own projects also to check it out afterwards and make it more understandable for you. So that means every project we work on will be shared. The questions is a very important thing. Ask as much questions as possible. That's why I'm here, and I try to answer them. Hopefully I'm able to answer all your questions, but I think I'm really sure that will be the case. Some links I want to share with you. No worries, I will copy paste this also to the chat. So give me just a second. EclipseStore, this. Here we are. These are all the links you need to have. So let me go through a little bit. So the first 3 GitHub repositories are the main repositories of EclipseStore. And the third link is the EclipseStore documentation. And last but not least, we have some trainings examples. This is my account on GitHub. There you will find all the different projects of the training. So feel free to join, check it out, search within whatever you search regarding EclipseStore, you will find it here for sure. About the certificate, in the same way then we share the video, we also share a certificate with you after, it's the same, something in between 4 to 6 days after the training. Your certificate will be available within our data grid platform. And I have to say there is one menu here, certification, and then you will see your certificate here, and you could download it and so on. An important information is here, you have to sign up with the same credentials or with the same email address you used for the training here. That enables you to see your certificate here in the platform. So as I said, 4 to 6 days around that, then you will see the certificate. Okay, So here we are. So that's okay. Now, finally, the topics for today. So we will start with the short or with the EclipseStore introduction. So that means after my short presentation here, I will hand over to Marcus, or Marcus will take over, and we'll go the EclipseStore introduction, all the theoretical things about EclipseStore and all the things you need to know. And then we start with a quick demo from my side. That means that is the moment you still could lean back and enjoy and have a look what's going on. And after that, that is the point where we can work together on a project. It's a step-by-step configuration project, how to use it, how to initialize, and so on. A lot of things we can clarify here. Then we have to talk about some CRUD operations, so create, read, update, delete, all the things that are important for a database or a cache or whatever you want to call it. Then we have to talk about a little bit about how to create a proper data model. I'm pretty sure most of you are able to create some data models, but in EclipseStore, some things are a little bit different, and we have to talk about this. Then there is an optional topic. It's regarding querying. Most of the time we are using the Java Streams API, and I'm really sure most of you are aware of Java Streams. I will go into streams a little bit when we're talking about the CRUD things here. Then I think that's mostly enough to give you an idea how Java querying and EclipseStore querying is working. Most important or more important is the lazy loading part. So due to the fact that EclipseStore is an in-memory technology, we still need a functionality to keep things on your hard disk. And that's why lazy loading is a really important topic. Yeah, last but not least, we need to see what's going on inside the database. So there is a client UI, or I have to say REST interface, to see what's going on inside the storage. And it's always a question from your side, what if data structure changed? And therefore we have our LegacyTypeMapping. That is the last topic for today. Feel free to ask any other questions beside these topics here. Maybe you are a more advanced user and you have a question regarding EclipseStore. Feel free to ask it. I will do my best to answer it. Sometimes I need to say, okay, send me please an email. I will answer this by email if it's more off topic then. Okay, so that's all from my side so far. So that means I will hand over to Marcus. Marcus, are you here?
Of course.
Then it's your turn.
Thank you, Christian, for your introduction, and welcome everybody to our today's online training. Thank you for joining. First of all, I like to ask again, who of you is new to EclipseStore? Please write in the chat. So it's important for me. It's because of so how should I go into more deep, or do you already know the functional principles? But as so already some people have said they have no experience so far with EclipseStore. So I will go through the functional principle and only the rough functional principles, and then I will again hand over to Christian, and he will go jump into code and show you how to get started with coding. So first of all, I like to announce that we have released EclipseStore version 3, and this is a very important milestone. So mostly we say when a new major release coming up, then this is very important and the most important release ever. But in this case, it's really true, and it's because we launched GigaMap, and this is a very important, convenient feature. This was the last missing piece of puzzle of EclipseStore. So it introduces indexing and fully automated lazy loading. and is also the foundation for our vector search we are currently working on. And so EclipseStore is now, I would say, it's completed. It was completed from version 1, but we have now all the convenience features. So we implemented all the feature requests we got the last 6 years, and so I would say we reached our goals. And the same, we have now released Eclipse Data Grid, and I hope this will not confuse you. So far, we were talking about EclipseStore constantly, and now there is Eclipse Data Grid, and it's simple. So EclipseStore is the Java persistence layer, the Java persistence framework for storing complex Java object graphs, but it's built for a single JVM. It's built for a single server node. And when we got started with EclipseStore more than 10 years ago, then the monoliths were standard architecture. Then now the microservices came up, and of course we want to build distributed applications, and so more and more people were asking for distributed applications, and this is why we worked on a cluster solution. And Eclipse Data Grid is now the cluster environment for EclipseStore applications. So you get started with EclipseStore, build your single JVM, single node application, and you don't have to make a decision whether you want to run it as a monolith or a distributed application. When your application is completed, then you can deploy it in an Eclipse Data Grid environment, and then you can run it as a distributed application or a microservice that scales horizontally. So and everything you need for the infrastructure is provided by Eclipse Data Grid, and Eclipse Data Grid or EclipseStore is also a part and a major feature of the Eclipse Data Grid. So in the future, we will provide more and more Eclipse Data Grid courses, and EclipseStore is a feature and a part of the Eclipse Data Grid. So the question or the main question is actually why we need EclipseStore. Why should we use EclipseStore as a persistence? Because we have databases, we have object relational mapping frameworks like Hibernate, and so why should we use something different? So when we started with the project, we had big problems, or we were working on Java IDEs. So we were developing a Java IDE called RapidClipse, and our users had challenges with persistence because database development with Hibernate, object relational mapping, and relational databases is challenging. And so many people had issues and had challenges with database programming in Java. So we tried to simplify database programming in Java, and also we wanted to eliminate all these latencies, and we wanted to get out of the most of the performance of Java. And so we tried a completely different approach. And why actually do we have challenges in database programming with Java? So and the answer is impedance mismatch. So it's because of the systems are completely different. The systems are incompatible. I talk about the system of a Java application and a database system. In Java, we have an object-oriented programming language, and so we can deal with any data structure, structured data, unstructured data, any data types. We have collections. Yeah, and so the programming language Java is not limited, and everything that's executed in memory is extremely fast. And as soon as we want to store data, there are a lot of challenges, and it's because of you cannot store your Java objects as they are in a relational database. So because the systems, the data models are incompatible. So there are a lot of challenges, and it's the same with the NoSQL databases. So they introduce new data structure or new data formats, but all of these database formats or data structure are also incompatible with the Java object model. So you cannot, what does this mean actually, incompatible? It means you cannot write your classes and store your objects seamlessly in a database. There is always a mapping or a data conversion required. Even if you use a graph database or an object-oriented database, this is not comparable and not compatible with the Java object model. And this is the reason why we need something in between. We need a mapping or a data conversion. And with relational databases, we have the standard, we have object relational mapping, we have JPA, and JPA providers like Hibernate to store objects in a relational database, right? And it's the same when we use a document database, for instance, then we need a JSON conversion or something like that, or a mapping to a graph database. However, mapping is also challenging, and the end result is limited in compared to your Java object model. You cannot use all data types that are supported by Java. The database data types are different. You cannot use, for instance, inheritance and so on. So there are many challenges. And data have to be converted through every single read and write. So through every single read and write, data have to convert it behind the scenes, or objects have to be generated behind the scenes. And this is a built-in break that slows down your application dramatically. So you should really check this out, measure how long it takes to read data from an EH cache on the EclipseStore IO website. You can see a live demo. It shows how long it takes to generate objects when you fetch data from a hot EH cache. So in this demo, we compare fetching data from a hot EH cache, generating the objects by using Hibernate, and searching and filtering on a Java object graph by using JavaStream's API. And just generating the objects is extremely slower, and there is no hitting database. So this is just hot EH cache data retrieving. So, and this might be the reason why many users have performance issues with object relational mapping frameworks. Yeah, and then what can you do? Of course, we can add a cache. That's really common for avoiding to hit the database with its slow disk access. Let's use a cache and store the result set in memory, and then we can fetch data directly from memory. That's great. But you should also measure how long it takes to fetch data from a cache. And so it mostly takes milliseconds. And this is actually very slow in comparison to accessing memory. And it's because if you get access to the memory by using a programming language like Java, it should take microseconds, sometimes only nanoseconds, for a lookup, fetching data from a cache or from memory. And this is the reason why we still might have performance issues even if we use a cache. And it's the same with the NoSQL databases. But the complexity increases as soon as you use a distributed or build a distributed application. So it is because of if you run your application on multiple nodes concurrently, and data is changed in one of these nodes, and you store data, you store your object in a database, then this node will be in sync with the database. But at the same time, all the other nodes are not in sync with the database. So this is a huge problem. And of course, this is also used, this is also solved because then we can change our cache strategy. And we can use a distributed cache running in between the application nodes and the database. And then you can synchronize your nodes with the cache, and then problem solved. But mostly in big applications, users would like now to even search and filter on the data in memory. So you have the data in a cache. You have faster access to these data in a cache. That's cool. So why not searching and now filtering on these cache data? So the problem is today's cache solutions, they do not support great searching features mostly. And this is the reason why in many organizations we can see searching servers like Elasticsearch running also in between the application and the database. And I show you this architecture overview because of we can see complexity is increasing more and more. And if you use if you want to process completely different data types or different formats like unstructured data, then maybe the experience is, oh, with relational databases is not so great. Maybe we should use a document database. But if you have really, really complex data structure, and we use relational databases, and you might have this experience if you use 3, 4, 5, 6 joins, then the performance will go down of your database. And so maybe a graph database will help you because it's built for high complexity data structure. That's cool. But maybe you have a sensor data you have to process, and then maybe you should use a time series database. And now Gen AI projects are growing more and more, even in Java. That's a great news. But maybe you need a vector database. In Java, we can process and we can deal with all of these data types. Databases cannot. They use specific data structure, and this might be the reason why there are so many different database types on the market. And if you have a big organization, if you're a big organization or build a huge application that deals with different data types, then you will run different database systems. And maybe you have a lot of users, then you will run a database cluster. And in the end, we came up with microservices, and then we have a lot of distributed services. And this is the final architecture overview. So very complicated, a lot of different data solutions we should use or we can use. It gets more and more complicated, and the infrastructure costs are skyrocketing. And of course, also the license fees. And you guys as developers, you need more and more skills about database programming and database itself. So the question is, can we simplify all of this? And we believe, and this was our goal, to simplify all of this and make it faster, make it more simple by introducing a Java native persistence. Before we jump into what actually is Java native persistence, let's have a look on the cost of databases. For instance, this is an example for a PostgreSQL as a service, 250 gigabyte at AWS. And it's just an example, so you can choose between different configurations. For CPU machine, 16 gigabyte memory, SSD, roughly $8,000 per year infrastructure costs for PostgreSQL as a service. And if you need more nodes because you want to distribute the load, high availability, and so on, of course, your price will double, will triple, and so on. And the interesting thing is the same amount of storage as a blob store at AWS S3 costs only 250, for 250 gigabyte costs you only $70. In comparison to a database, it's nothing. And the blob store is also fully managed by the cloud provider. And now the question is, can we combine this, the performance, the power of Java, with the low data storage costs of the cloud providers? And the answer is yes, we can combine this and we can get out best of both with EclipseStore. But actually, EclipseStore is not the core of all of this. The core of all of this, and this is the cool thing and the great news for you guys, is Java. Because Java is the language that can deal with all these data types, all these data structure. We have everything we need in Java. Executing a Java program in memory is extremely fast. We have a JIT compiler. It accelerates your application dramatically. It's almost as fast as a C program sometimes, because JIT compiler is very powerful. And we have a great data structure. Java, we have the Java object model. It allows you to deal with simple lists. It allows you to process structured data, unstructured data. You can deal with vectors. You can create a graph model, a high complex graph model with millions or even billions of nodes in your graph, circular references. Everything is possible in Java. You can use collections, so everything is possible. And we have the Java Streams API for searching and filtering in memory. And using Java Streams is also extremely fast, which means if you compare a SQL query with a comparable Java Streams query, then you will see that the Streams API will be executed between 10 to 1,000 times faster than the comparable SQL or JPA query. And this is really a big deal. So performance issues are eliminated with pure Java. And it's also enormously convenient to build data structures in Java. Of course, we have our language. So what's missing? Here is an overview about the native Java features we can use for data processing. Native Java object model, Streams API as a query language. We can implement any logic. So the databases provide you, or most of them provide you, stored procedures and mostly a query language or a language for implementing stored procedures like PL/SQL. But in Java, we have a much more powerful language. We have a great JIT compiler now, JVM. What's missing? So for professional data processing, a lot of features are missing in Java. We have no indexing, we have no lazy loading, because, okay, if all data are in memory, we can search and filter with Java streams, but should we load our whole database in memory? Yeah, why not? Because there are also in-memory databases on the market, but if we could have lazy loading would be even better, right? What about locking, full text search? What about ACID compliant transactions? And so on. And what about running all of these in a cluster, in a distributed environment? All of these features are missing. And with Eclipse Data Grid, you will get now all of these features. All of these features are provided by Eclipse Data Grid. And one of the most important features is storage with EclipseStore. So with Eclipse Data Grid, you will get actually now 3 open source projects, 3 Eclipse open source projects in one. So the Eclipse Data Grid uses the EclipseStore persistence framework for as an ACID compliant persistence, and it uses Eclipse Serializer, and it's also used by EclipseStore. So it's the core of EclipseStore. And Eclipse OpenJ9 is just an example for a very powerful JVM you can use for in-memory data processing. But it's not mandatory. It's just a suggestion, and you can choose your JVM freely. So the Eclipse Data Grid provides you indexing, GigaMap, which is fully automated lazy loading, provides your locking API, a Lucene full text search integration, an ACID compliant persistence, and this is EclipseStore, an object graph replication that allows you to run your EclipseStore application in a cluster, in any cloud environment, on premise. So allows you to distribute your application or microservice that uses EclipseStore. And EclipseStore is the persistence framework that is the main feature of all of this. And to get started, the best way is, of course, to get started with the Java core features. You should know about object-oriented programming with Java, Java Streams API, and so on. So core Java features, and then get started with EclipseStore. And here we can see the architecture overview of an Eclipse Data Grid application. So you can run a distributed application, or you can run a monolith, microservices, and then you can also keep your database with Eclipse Data Grid and use it as a cache layer, and put all the data processing features into Eclipse Data Grid in this layer. Then you have a powerful Java layer. It will be extremely fast, and this is just one architecture example. All right, but you can also use Eclipse Data Grid without a database system and use it as a primary data storage, because you have EclipseStore as a persistence framework. And now these are the 2 options. And now this leads me to a very important point. So far we were talking about EclipseStore is a data storage for Java objects, and you don't need a database at all. You don't need a database system anymore. Just core Java and your objects. In practice, we have learned in practice this can be also challenging, not from technical perspective, but maybe with your colleagues. And it's because of one day you have a discussion with your database teams or your database team. It always depends on the organization structure, of course. But mostly in big organizations, you have a database team. And if you tell them, now I have EclipseStore, I only need Java for store my data. I don't need you anymore, guys. Goodbye. Maybe this will be challenging. And this is the reason why you can now run Eclipse Data Grid as a caching layer and keep your traditional database. But EclipseStore is even in this scenario, I go back to the distributed cache environment. So here we have Eclipse Data Grid running, and we have the database. We kept the database. Even in this scenario, EclipseStore is used for storing all operations, all data operations, and distribute the data operations through a cluster environment. So EclipseStore is used even if you use Eclipse Data Grid as a caching layer. So EclipseStore is always the entry point when you work with Eclipse Data Grid. I hope this is not too confusing. EclipseStore for a local storage, storing object graphs, Eclipse Data Grid for running all of this in a cluster environment. You can keep your database, but you also can remove your database and just use EclipseStore as a persistence framework. And then you don't need a database at all. So you decide. Okay, this is, let me go through over this slide because this is more information about the Eclipse Data Grid. But today the topic is how we get started with EclipseStore. So as I mentioned already, it is a Java native persistence, which means, what does native mean? It means it uses the native Java object model. There is no conversion to any other data structure or data model. It uses the native Java object model. And this is the only storage solution on the market that uses the real native Java object model and can deal with all Java types. You can store complex object graphs or even subgraphs persistently on disk by using EclipseStore. And vice versa with EclipseStore, you can load your object graph in memory, restore it in memory at any time. And the cool thing is you don't need to load the whole object graph data into the memory. You can also just load subgraphs, only these object references that are really needed through runtime, which means you can have a 250 gigabyte database, but you run only a 4 gigabyte memory server instance. This will be possible thanks to lazy loading. And this is roughly what EclipseStore provides. And to store your changed objects, just have to call a store method. That's it. And each store method is a transaction safe operation. It's an asset compliant transaction safe operation. It guarantees you that the data is really stored persistently into any data storage. So you can also choose your data storage freely. You can store it in plain files. You can store it in a binary object store, a blob store like S3, or any other storage target that can deal with binary data. And this is what EclipseStore provides you. EclipseStore is also a part, it provides an integration for Helidon. So it's integrated with Helidon, which is a microservice framework. And it's also part of Micronaut. It's well integrated with Micronaut as a microservice framework. We also provide integrations for Spring Boot. There is also a CDI integration. You can run this with Payara Micro, with Quarkus, and so on. So I explained it already. EclipseStore Persistence, it's a kind of storage engine for object graphs, for Java object graphs, to store it on disk and to restore it in memory when needed. The architecture is very simple. Just need your pochos. You can design your object graph, your object model freely. We always talk about object graphs because mostly it's organized. The objects are related, like in a relational model. And so this is mostly a graph. And you can also build very complex graph structures with circular references. You can use inheritance. So everything that is possible in Java, we can store it with EclipseStore. Now, EclipseStore gets a new powerful feature, and this is GigaMap. GigaMap provides you indexing. And it's because a lot of people told us the last years, yeah, this sounds really cool, but I have to load my whole data in a memory to search and filter with Java streams, right? And I don't want to do that because there are a lot of traffic and this can't be efficient. And that's on one hand true. On the other hand, we were able to use EclipseStore and it worked well by segmenting the data structure. But of course, with indexing, it's super fast. It's very convenient. And GigaMap also introduces fully automated lazy loading, so you don't have to care for your lazy references. And it's super convenient. And it's now released. You have it as open source. And by the way, all of this is open source under Eclipse public license. So it's a very liberal license. You can use it for commercial software and building proprietary software, of course. So EclipseStore combines or is a bridge between your objects in memory and the storage target. And EclipseStore creates a binary representation of your object graph and stores all object graph information in a binary format appended to the file storage. So if an object changes in your graph, you just have to call a store method. Then EclipseStore will generate a binary, like a micro snapshot of the changes from the delta of the changes, and stores the micro binary appended to the file storage. So each store operation creates a new binary in your file storage. It's transaction safe. There is a transaction journal that guarantees that data is really stored in the file storage. So the consistency model here is full consistency. So how the architecture looks like, here we can see this is the traditional architecture of a JPA application, objects in memory, object relational mapping framework like Hibernate, a cache, a local cache, your JVM. What we are doing now is we replace the object relational mapping framework and we remove the cache. Wrong direction, sorry. So, and then we replace the object relational mapping framework with EclipseStore. You don't need a cache. because we keep the object graph in memory anyway. We search and filter on the object graph by Java Streams API, so we don't need additional caching framework. We only need EclipseStore. So lower complexity, and we don't need a database at all. We only need a binary data storage. So this is really lowest complexity in terms of data storage, lowest possible complexity. Here are some numbers, but you should check out the performance demo on the EclipseStore IO website. And you should check this out and prove that whether this is really true, what I'm saying. And here are the components you get with EclipseStore. So the core of this is Eclipse Serializer. So to generate the binaries, we use the Eclipse Serializer. We do not use the Java serialization. There are multiple reasons. So the Eclipse Serializer can deal with any Java types. It can deal with any complexity. The depth of your object graph is not limited with Eclipse Serializer. It's faster than Java serialization, and it is way more secure because it does not execute code through deserialization. So injecting malicious code through deserialization, and thus deserialization attacks are impossible with Eclipse Serializer. So, and you can use Eclipse Serializer as a standalone project. So if you want to build, or if you need a high security serialization in your project, you can check out Eclipse Serializer, and maybe it can also help you to make your applications or your frameworks more secure. So Eclipse persistence is available for the JVM, of course, and it's also available for Android. So if you build Android applications, mobile apps, then you have the same persistence with EclipseStore on Android. By just serializing objects on disk, there are so this is not a new idea. So this is well known since decades, but it's also linked to a lot of further challenges. So, for instance, what if my classes change? Then I'm in trouble. And what is if I want to distribute my application? So there are so many challenges, and we have solved all of these challenges and provide you solutions. And one is LegacyTypeMapping. So if your classes change, you can use the LegacyTypeMapping feature for schema migration, and this is really convenient and very easy, way more easier than schema migration with a traditional database. Then we have a file system garbage collector. So I mentioned already that each store operation will create a new binary, a micro binary in your file storage. So your file storage grows more and more. And it's the same when we delete objects. Even if we delete objects, we create a new binary. So we never or if we added data, it's the same. So we never overwrite data in a storage. So, and to avoid that your storage will grow endless, we have a file system garbage collector that removes the older object versions from your file storage constantly behind the scenes. It's highly configurable, and maybe Christian will tell you something about also the garbage collector. There are file system abstractions, so you can choose your storage target freely. Your storage can be everywhere, can run separated from your app. Then we have database connectors. This might be the most confusing part of EclipseStore, and it's because of with EclipseStore, you don't need a database anymore, but basically you can use a database to store your objects because databases can store binaries. And so this is the reason why we have database connectors for the most popular databases. So you can decide whether this makes sense or not. We built these connectors because one of our customers one day had a big problem. They were excited about EclipseStore, but they were like, "Oh, sorry, but we have to use this database. We have bought the licenses and we have contracts for 10 years. Sorry, we have to keep the database, but we would love to use the functional principle." So this was the starting point why we decided, okay, then we will provide you a database connector, and then you can keep your database system, and run EclipseStore with your database. All right, so we have a REST interface that gives you access to the storage data so that you can have a look on what actually is really stored on disk. And we have a user interface that allows you to browse through the storage data, that you have an overview about the data written on your disk. We have native backup functions, of course, and so on. Converter for CSV, for instance, for importing data and exporting data. So EclipseStore is an open system, and all of this all together is EclipseStore. This is an old slide. It shows you can run. It's because EclipseStore is just a tiny Java library. You can run it everywhere. You can run it wherever a JVM runs. And it works even with GraalVM native images. Can run it in containers. And the only requirement was so far Java 8, but now we are on, with the latest EclipseStore version 3, we are now on Java 17. So that's the only requirement. Of course, you can use it also with JVM languages. Here is our overview about the supported storages. And I like to repeat one important point. So this is memory management or memory usage. EclipseStore, when you start an EclipseStore app, it will load your whole object graph into memory. But only the object IDs are loaded into the memory. So you have all information about your object graph in the memory, but not the data. The data is not loaded automatically. You as a developer, you can decide whether you want to also preload data into memory or not. Then only the object IDs are loaded, and so you have a fully indexed object graph in memory, and data is only loaded when you get access to your objects by calling a get method. Then the object reference is loaded and the object is merged into the object graph. This is the functional principle. And this is the reason why you can have big memory sizes, and you should use big memory sizes because then you can preload more data into memory, and then everything runs in memory. It will be extremely fast. You will minimize your I/O operations. So it's in memory technology, so it makes sense to use memory. And as we save a lot of instances, machine instances, because you don't need a search server anymore, you don't need 3 or 4 or 5 database systems anymore, you will save a lot of infrastructure cost. So please invest in more memory. But for every reason, if you have only small memory machines, it will work. You can run it even with, maybe Christian will tell me, no, this will not work. But theoretically, you can run it in with 512 megabyte memory, but it depends on your storage size, to be honest. So, but it should show you that the functional principle is you don't need to load the whole database, your whole data in memory. Very important. All right. I could now go into more detail, but actually this is Christian's part. I have prepared a lot of more slides that show you how it works to load objects, to store objects, and so on. But we will provide the slides also for downloading, and yeah, you get the recorded sessions anyway. And then I like to hand over to Christian, and now we jump into the code, and Christian will show you how to get started coding with EclipseStore. I hope I'm not too late this time, and I should be in time. Are you, Christian?
Yeah, thank you, Marcus. Sorry, I couldn't find the button to.
Now you cannot believe that I'm already done, right?
Okay. So let me share my screen.
And by the way, please ask as many questions as possible. This is I try to answer the questions, and Christian is one of the people who write the code, who is designing all of this. And so, yeah, take the chance and ask the technical questions. There are no stupid questions. And also, if you have some doubts, or if you're confused, or if you say this can't be true, or give us feedback, everything, good feedback. Now give us not bad feedback, only good feedback today. So it's super important for us to hear what you think about EclipseStore. Thank you.
So thank you, Marcus. Great. So now it's on me to bring all the evidences and the answers to all your questions. So I tried to answer a lot of your questions from the chat, and there are a lot of stuff which is, yeah, I leave it as it is, and we have to clarify it. It's around of when to use EclipseStore, the different use cases maybe. And I think I could answer this during my part of the presentation. Whenever we touch a project, I will give you the hint, what is the use case here, and why to use it this way, and so on. Also about scalability and so on. This will also always be part of my presentation. Yeah, and if I missed something, just let me know. So at the beginning, as I told you, we are starting with a really small basic example. So you still able to lean back and just look at it. I prepared some code for you, and I would say this is the first use case. It is the very basic use case to store something within your application, no matter if it's what it is. It's for example, two customers object like this one's here. So oh, come on, that is no longer possible. So just a second, I need to remove that. So every time I'm running my Zoom presentation, I'm not able to use my shortcuts anymore. So that hinders me a little bit. So, okay, now, so we have these two customer objects that I created here. And the idea is to store them. So that's the easiest use case. So whenever you need an embedded database, for example, for smaller applications or so, feel free to use EclipseStore as a storage provider. So we want to store these customer, and when we want to store them, we need to add them to a structure. So for example, a list of customers here. So but you see there is a my company object, and that brings me to the next point. When we have a look into that, you will see that my company object is here, and that this object contains a list, an array list of customers. So when we're talking about EclipseStore, we always need an entry point on the top level. So we need a top level object to enter the object graph. And in that case, the my company object is the entry point, and it enables me to go deeper, adding more lists and so on, and collections and whatever to store it. So, and in that case, my company is my root object. I would call it root object, and it contains that list, and with some get and set methods. let's jump back. So, and this is the point where I initialize, I have initialized that my company object here, and I added these customers to that company list object. And now we need to store it, right? So we need to somehow get it stored to the hard disk, and therefore our first most important object, I have to say, is the embedded storage manager. So the embedded storage manager is, let's call it the database management system of EclipseStore. And you will get these embedded storage manager. At that moment, you add the following dependencies. So these are the most important ones. To be honest, the version is not the newest one, but the example is an old one, but still works for the training. We are currently now at version 3.0.0. So this is the newest EclipseStore version. So feel free to use it. The only restriction is you have to use Java 17 for it. Everything below is running with Java 11, I guess. But it's totally okay to use 1.4.0. So that's so more important is you need the storage embedded. This is the main dependency you need. And there is a second one, which is called storage embedded configuration, that enables us to do some further configuration stuff, like tell him where to store or where to have the binary files, for example. So, okay, these two dependencies are needed, and let's jump back, and that enables me to create an embedded storage manager. So in that case, I call it storage manager, and this is the way to start. There are 1,000 different ways to create such a storage manager, but the easiest one is we call the embedded storage.start method. We have to hand over the root object, because this is the moment where the embedded storage manager noticed, okay, that's the root object and that's the entry point, and everything below is I have to store, and we need to add a path to tell them where to store the binary parts. So we will see that a little bit later. Okay, so at that moment the storage manager is available. I need to call a store method. So at that moment, I'm added these customers to the my company and to the list within my company. I need to call a store method, and that's also an important situation because we always said, okay, we are in memory, but if you want to store something, you have to call a store method. So that's important. And one special thing is here, we always have to store the object which has changed. So that means maybe you are used to store the object which is created, for example. So let's say in any relational database, mostly you call a save method and then you hand over the object which needs to be stored. But on EclipseStore, it's a little bit different. You always have to store the reference holder. So, or yeah, I have to say the object which has changed. And in our case, we added something to the list of customers, and that's why we have to store these lists, because we changed it. So, and that's exactly the point. So I hand over my company.getCustomers, and that's all. And that's all we need. So this is the only code that we need to store these two objects to the hard disk. So I just want to enable the shutdown mechanism here to shut down the storage at the end of the script. So let me store this and let's try to run. So let's run it as a Java application. So we see something happens here. I would say the most important things that we need to have, so far, no worry about this. More important is that something happens to the left here. When we now give it a refresh, you see that this data folder was created, and it consists of a channel file and a persistence type dictionary. I will come to that a little bit later, but this is the part where the data is stored, right? So this is what happened here. Okay, so now the application is no longer up and running. So, and the data needs should be stored, right? So let's give it a try. So we do not need this anymore. Come on. So let me just delete it so it's easier for me. So, okay, so we need that root object. This is still important because it's the entry point. So we have to initialize the storage manager. We do not need that store anymore. So we also have to remove this. And this is what we need to have. So we want to stream through the list of customers, and for each customer in that storage, I want to print out the mail. So that's what should work now. So let's start the application and see what happens. Need to store it for sure. Okay, so application is done or runs. So let's search for the two mail addresses that needs to be there. Come on. Maybe, no, I'm too far. Where is it? Can't find it. Ah, here they are. You see that? So you see, this is the, I would say the evidence that the two objects are stored to the hard disk. And this is how EclipseStore basically works. So this is the very, very basic, it's a very, very basic example. The only thing you need is that storage manager here, and it takes care about to handle your in-memory stuff and store it to your hard disk. Okay, that's easy, right? So that's a very basic example. So this is what I explained. This is the first use case. Whenever you need a storage in your application, just feel free to use this. In this case, it's just a framework, and feel free to think about any use case you want to have with that. And but I will bring you to the next case. So, and therefore, I created a step-by-step configuration project. And let me share this with you. Just a second. Okay, copy this to the chat. Okay, so this is the GitHub repository where you can find the step-by-step configuration project, and feel free to check it out. So to check it out to any IDE of your choice, and it is a Micronaut project, but it's not on Micronaut itself. I regularly use Micronaut as a project base layer of my training projects that makes it easier to create a REST interface and to load and save and add some data. Otherwise, I always had to create some UI stuff, and that's not what I want. So therefore, I always use Micronaut. As it could also use Spring, but I'm more into Micronaut. That's why I chose it. Okay, let me just clean up a little bit, and that's the project I want to start. There is one branch, and the branch is the name is one beginning, and I also want to start at this branch here. So as I said, feel free to check it out. The only thing you need to adjust is you have to check if annotation processing is enabled within your IDE. For Eclipse usage, you will find that point when you search for annotation processing, but mostly under the Maven section here, and you have to enable the annotation processing. That's important. So when you check out the project, you have to check if annotation processing is available, and if yes, everything should be okay. Just to check this out, when you check out the project at that beginning branch, you should see that there is one file which is called application here. And you could give it a try. Just right click on it and run as Java application. And you should see an output that, just a second, I need to make a Maven update here. So let me just update the project. And now, so this is what you should see. So when you start the application directly at the application class here, you should see the Micronaut section here, and you see server is up and running on HTTP localhost 8080. So that's what we need. So if you see this one, this here, then we are good to go to start with the first stuff that is needed to use EclipseStore. So, and by the way, that is the next use case I want to talk about. Due to the fact that we using a Micronaut here as a kind of like a data provider with REST endpoints and so weiter, this is the next stage of use case. Use EclipseStore not embedded to your application server maybe, but as an external data provider application. So that means whenever you want to create your, it's kind of like creating your own database or your own small part microservice database for storing smaller things beside your big database. Let's say that's always things that we recommend, that not to replace your relational database, but making smaller data parts available in a high performance way. And maybe at the beginning as a cache, but later maybe as a standalone storage service that runs beside your database to provide the data. So whenever you need to access data from multiple applications, you could create such a data provider service. And by the way, you would do anyway. So whenever you want to provide data to someone else, it is best practice to create such a data provider service and not let them access to your database all the time. So, so this is the second use case. Okay, are you ready? Can this file be loaded by another JVM process? Yes, of course it can, but not at the same time, because this is one of the I would say the biggest don'ts of EclipseStore. Do not let two JVMs accessing one storage. So that's the biggest that creates the biggest issues on that. And there is, by the way, there is one mechanism behind. It's kind of like a lock in EclipseStore that prevents from concurrent accesses of multiple JVMs to one storage. But of course, this process can be run by any other Java process that has the same data structure in it. So as long as there is the same data structure, this will totally work. Okay, so let's start with the step-by-step configuration, and I need to follow my GitHub repository a little bit just to not forget something. So the first thing we need is we need to add the dependencies that is needed. And in our case, let's jump into the POM XML, scroll down, and we need the two dependencies. I will copy paste them from the project. And as I said, we upgraded a little bit from version 1.3. We use 2.3.1. So this is that's the version which I know so far that works great. So give me just a second. Did I have something wrong so far? No, but I have to check the versions. Give me just a second. No, it's okay. So we're using we're letting the version like it is. That's totally okay for us. So this will work fine. Okay, so we are using the 1.3.2. That is totally enough for us. And yeah, that's all we need. So that's the first step. So feel free to move on to the next step by yourself. So if you lose, you could go to the next branch step. The next one should be project setup done is the next step, and that's the step where those dependencies are already available. Okay, so let's move on. Let's jump into the Java classes. So we have our, just a second. So we have our dependencies in place. Next step would be, let's create some Java classes. So, and therefore the first class I need to create is a DB class. So right click here, let's create a new Java class. Oh, come on. So new Java class, and I call it a DB. And that's totally okay for me. And I also have to say, when we are using Micronaut, but I'm still using some very, very basic, let's say, coding practices. So I'm using static stuff and so on, because it's the training is more focused on basic stuff and on EclipseStore stuff. I know there are all that injection stuff, and in reality, I would use it. But for now, it's totally okay to use such static classes and so on to give you an idea how EclipseStore works, basically. It's more important than having those fancy injection stuff, and but I will also provide projects with that stuff to you. Okay, so let's create a DB class. And as I said, I want to start with a static block here. And also the two major classes that is needed. So the first one is the public static embedded storage manager, and we call it storage manager. That is one thing we needed. So that's the most important object. And at the second time, we need a data root object. So this is what I mentioned earlier, that the entry point, and therefore we need an object here. So let's create another one. Let's create a class which is called data root. And that is one of the very first differences of having a company, for example. You remember I used a my company class at the beginning at the first project, and now I used an object which is named data root. And this is totally on you, using a synthetical object to handle all your classes below, or you use an object that belongs directly to your business, or which is related to your business stuff. And therefore, data root is just a synthetic object that helps me to entry my my data structure. So data root, it's okay to have it like this. So, but we need to create an instance here of data root. So let's say public final static data root. Let's call it root, and let's directly initialize this new data root. Okay, so next step is to create that static block that is needed to initialize things. Yeah, it's there is one question: can data root be thought as a database and the member of the data root be tables? Yes, of course. Yeah, in a way, that's right. We were talking about the data structure a little bit later and what is best practice for data structure, and this is also a part of that. But yeah, if you want, it could be a structure like this. Data root object is the database itself, and all the things below the sub objects or the child objects are tables or whatever. Yeah. Okay, so now let's initialize our storage manager. So that, let's say storage manager equals, and we use the builder pattern now. So embedded storage manager dot builder. Sorry, embedded storage configuration. Sorry, my fault. So this one is needed. Embedded storage configuration, and we use that builder pattern here. And let's say builder, and that enables us to set up the whole configuration of the storage itself. And the first thing what we need is we need to set the storage directory. So this is where the data should be stored on our hard disk. So when you're asking for, let's say, how to containerize this or use it within Docker or Kubernetes or whatever, then we would recommend to use persistent volumes, for example, which is attached to your container to store things on it. So set storage directory, and let's call it data in the same way than before in the example. Then that's all we need because there is nothing more needed here. And now the second part comes based on that configuration we created here with the builder pattern. We need to create an embedded storage foundation. So that is an underlying foundation. So, and therefore we create embedded storage foundation. And based on that foundation, we create an embedded storage manager. And here, an important thing comes into play. So we need to hand over the root object that is created above here. And last but not least, and you should never forget this, you have to start it. So that's important. And that is a mistake also happens to me. And I searched a lot and couldn't understand why it doesn't work. And then I forgot the start method. Okay, so this is everything you need, initialized in a static way, but totally fine for us. At that moment we access the database, we will get the data back. Okay, so another thing we should not forget is the data root. So it's still empty for now, and we need to fill something in. And we also talked about this. I want to create a new array list here. Something went wrong here. Data class data root. Okay, yeah, got it. So let's create a list, Java utils list, and let's store books in it, or a book object. Let's call it books equals new array list. Okay. And let's say, okay, we have book here, and then we need book there. So, and of course we need these that entity somewhere, and therefore there is a domain package already prepared here. And let's create that book entity directly within the domain package. Come on, that's not what I want. So right-click, new Java class, and let's call it book. Okay, within that book entity, we need some example fields. And therefore, let's start with a private string ISBN. That's one field we want to have. Another one, private string. Of course, we need a name of the book. And last but not least, we need an... Yeah, just stop it here. That's totally enough for now. So let's create some, what is the... always the same switching from Eclipse to IntelliJ, and I couldn't remember the shortcuts. Yeah, doesn't matter. So let's create some get and set methods, but I couldn't remember. Here we are. So okay, so let's generate get and sets. And we also have to generate a constructor using the fields and also the default one. Okay, here we are. This is also a special thing on EclipseStore. We do not use any annotations for mapping and so on, because we do not have to map something because our object structure is the storage itself. So there is no annotation needed, just pure Java classes. And for those of you who want to know, is it working with Apache Lombok, for example, it is. So feel free to use any tooling here using Lombok for having get and sets and constructors and so on. That's totally on you. So this will work. Okay, so we need to import the book. We use it like this within our data root. And also within the data root, we need to have a get method, of course. So let's do so and generate. Okay, great. So let's double check if everything is available so far. Any questions from your side? There is one question about when EclipseStore needs to look up an object by ID from the storage file because it's not in memory yet, will the lookup be fast? Of course it will be fast. And I have to say, this is the real concurrence, I always say, because to a normal relational database, let's say we have a relational database without a cache, that's important. And we have, on the other hand, EclipseStore to compare it. Then both systems will work the same in a way. Both systems need to load the data from the hard disk and need to transfer it. Maybe on the relational database side, you have a database server somewhere. The database server itself has to look up for the object, and then it needs to be transferred, and then Hibernate comes into play and need to do some OR mapping at the end, and so on. And this is the biggest disadvantage of, or the biggest trade-off on relational databases, all that OR mapping stuff. And it's a real heavyweight process. And this is why EclipseStore will be much faster, because we do not have that OR mapping stuff anymore. And the second point is the data is directly available below my application. So it just transfers the data directly from your hard disk to the RAM, and it is much faster than any other relational database. Won't EclipseStore have to go through the whole file storing, the whole object graph in order to find it? No, not really. So even when we have let's say that list here of books is lazy loaded. So that means that the object itself stays on the hard disk. So there is a kind of like a proxy object in the background. It's kind of like a lazy wrapper object, and based on that object, it's quite easy to look up for a specific object. But if you want to do some more extended search, you always have to go through that list, because you are just operating on your object graph. So it's not necessary anymore to stream or to look through a huge table of data. This is no longer the case in EclipseStore, but I will come to this a little bit later. Okay. Let's move on. So we created the data root with the list and books and so on, but I want to add one more layer to it. So I want to add another field to the book, and that field is called author. And author is a sub-object of my book entity. And let's create this author object. So let's say new class author. And I think it's enough just to have a name on that author. No, there are a lot more. Yeah, anyway, so let me just copy paste this to the class, and let's go through. So we have string male, string first name and last name. That's all the fields that are needed. We have the constructor here and some get and set methods. That's on it. You feel free to copy this also from GitHub directly into your class. or switch to another branch. I would say next branch, the next interesting branch for you would be then create entity and register, or maybe you jump directly to controller, create books done. That will also show you the controller directly. Okay, so I created that author class with its fields, the book itself, which contains the author. And that's what I talked about. A little bit later, it will be more clear. We do not have a huge list of authors anymore. That means when we search for an author, we have to search through the books maybe. And there are a little bit more to know about that, but this is the point where we do not have those huge lists anymore of thousands of authors, for example, because our object graph is a graph itself, let's say, and mostly we navigate through the graph with a specific context of data, and that enables us to we do not need those big search SQL things anymore. Okay, data root is registered. We have books here. Everything is in place. The database is initialized so that this will work. So last but not least, we need one controller to access all my data. So, and therefore we want to create a book controller. So let's say new Java class, let's call it a book controller. So this is the class who provides me the interfaces to access. What we need is, this is a micronode part, we need one annotation here for, say, for controller, and we need to set the URL part, and let's call it books. Let's do it with a slash books. So whenever we call localhost 8080/books, we should be here. And then we need to create our first create books method. And this is also a method that I just copy pasted because it's a big blob, I have to say. So that we start with a get method. And again, feel free to copy paste this from the repository. We need to import the HTTP response. So we could do it the short way to auto this domain book. Okay, here we are. So I just have to check. Okay, so my book, the author is missing here. So let's add the author because the author is missing here, and we need to this dot author equals author. That should do the trick. Yes, exactly. So do not forget to add the author to the constructor of book here, and do not forget to assign also author to the field at the end. Get and set methods. The method is still missing, so we need to create that author get and set. And here we are. As I said, feel free to move you through the branches at the end, and then you will see the result also. So I created two authors, and I hand over these two authors directly on instantiation of the books here. And then that's the interesting part here. So that's the moment where I go to my database. So I call the DB class and ask it for the root object. And the root object leads me to my get books collection. And here at this point, I use the add all method to store all my book objects here. And you don't have to care about the authors. The authors will be stored within the books because books are created, then also the authors also are created at the end. One important thing that needs to be done is to store everything, because so far this is pure Java stuff, right? So this is nothing really special or nothing EclipseStore related. When you create your objects, you have to edit these objects to your collection, pure Java. This is the first step where EclipseStore comes into play. db.storemanager.store. And remember, you have to store the object which has changed or the reference holder. So reference holder is our collection here, the get books collection, and therefore we have to store the collection itself. Of course, we need to return a response, book successfully created. That's all we need. We need a second one, a second interface one, but it's a quite small one. Let's create it, get. Of course, we want to get back our books. So let's create a public list of book, and let's call it get books. That's all we need. Just a tiny small method. And here we will add return. And guess what? It's quite really straightforward. Let's call our DB class.root.getBooks. Okay, so that's all we need. So when we want to access our data, we just call the same values, the same in-memory data structure to get out our data. So nothing more to say about this. And with that small program, so I think we are ready to start. I hope I did not forget something, but yeah, we created our own small, tiny data provider with a book controller class, with small domain classes. And this is what I talked about, creating smaller independent microservices for provide data to someone who needs to consume it, and not storing everything in a big monolithic database anymore. So feel free to choose the architecture that you want to have at the end. Okay, let's give it a try, right? So let's check it out if this is working as expected. So let's jump into the application class, and I should not forget to do a Maven update just to be sure everything is packaged and cleaned and so on. Okay, let's start it. Fingers crossed. It's always hard to do live coding, I have to say. Okay, so far it seems okay. Startup completed, and the server is running on HTTP localhost 8080. So let me jump into my browser, and that's, by the way, this is the reason why I choose get for storing things, which is also not best practice, I would say, but it makes it easier to call it by browser. So, and that's why I created, so I navigated to my browser and I called localhost 8080/books, and I get back an empty result, and that shows me that everything seems to be working fine. So that's the result from the get books method here. And let's go on and choose the create method. So let's say /create, and I get back the method book successfully created. And when we now call the books endpoint again, you should be able to see this well structured JSON output here. Yeah, really great. And no matter if we restart the application, at that moment, you see EclipseStore is initialized here. You see embedded storage manager is created, the type handler is created, and so on. And now feel free to stop the application and start it again. Let me just jump back into my browser. At that moment, we call that books method here. We should get back the same result again. Here we are. So that means your books are persisted to your database or to your hard disk in the same way. So by the way, in the same way that any other relational database would write down the data to the hard disk. So because this is the idea behind why to send data somewhere to store it to a hard disk, and why not doing the same directly within your Java application. That's the mindset behind EclipseStore. Okay, does it work on your side? Just let me know. So at that moment, when the application starts up, because we did not use any lazy loading stuff here, data is loaded directly into the RAM. So so at startup, or let me be more precisely, at that moment we accessing the DB class when we instantiate the root and the embedded storage manager, then data is loaded into the RAM, the whole data, because we are not using any lazy loading functionality. And that brings me to another point, when we talk about memory consumption and so on. The memory consumption will be one to one, I have to say, in the same amount of a little less than the memory is needed on your hard disk. The same amount of memory you will need as RAM. But in our experience, especially with project that we run on our customers project, then we see that we will need less RAM than with any other database solution, for example, that has an EH cache in between with Hibernate and so on. In most of the time, we need less memory than with a cache and Hibernate and so on, because the more you have to consider, the more concurrent user you have on an application server, the more cache you will need to cache the session data and so on. And another point is you always have to consider that you need RAM for your database and for the application server. And yeah, most of the time we need less memory than with a normal relational database with cache. Yeah, that's important. Okay, any questions so far to that step-by-step demo application? If not, so let me just double check if I missed something within the chat. Once restarted, I took 2.4 seconds to get all book on my machine, at least. So it depends on how many. Is that 2.4 seconds? Is it the num to load all the books on startup, or is it just streaming through the books, or are the books lazy loaded? And the question is, how many books do we talk about? 100,000, or how much book do we talk about? I mean, when we're talking about, let's say, 1 million books, I would say, okay, that could take 2.4 seconds to load all of them. Okay, let me just check. The one about using EclipseStore as a cache. Yes, this is basically possible in the same way using EclipseStore as a cache layer with Hibernate, in combination with Hibernate, in the same way that you could use EH cache, of course. To be honest, I never measured the differences between EH cache and EclipseStore, but I'm pretty sure they might be equals from the performance aspect. But I would say this is not let's say, the most recommended use case. It's possible because it's a caching solution, and it's an in-memory data storing or data handling solution, but it's not the main purpose of EclipseStore. When we're talking about cache, then we're more talking about a cache in between your database and application server as a search server, for example, or to accelerate access to your database, for example. It's not the primary focus on using EclipseStore as a caching provider for Hibernate, but it will work. I hope that answers the question a little bit. it's more on the whole process of loading data, OR mapping, caching in between, and so on. That all could be I would not say replaced, but it makes sense to use smaller chunks of data, cut it out from your monolithic database, and provide it within EclipseStore. Okay, so maybe I could get into this a little bit later. So last but not least, I want to jump to the next next example. I prepared a small CRUD project, which is here. Let me share the repository with you. Just a second. Need to find it. Always the same. Here we are. Okay. So that's the link to the next project. So feel free, check it out or follow on the GitHub page. So I already prepared this example here. Let me clean up a little bit. Okay, here we are. So just to give you an idea what's going on within the project. Here I created some mockup utils and I provided some mockup data. So we have authors here, around 50 authors, and we have books here prepared within the JSON file, around, I guess, 1,000, right? So that's what we have here, 1,000 books. And this is barely this, or it's nearly the same structure like in the other project. It's a little bit different how it's initialized because we are used a MicroStream or EclipseStore XML file to having all the configuration stuff in place. And maybe an interesting part is here the channel count. So you might ask, what is the channel count? Channel count means it is the amount of threads to write data down to your file storage. So because of data lock and so on of your operating system, it sometimes makes sense to have multiple channels or multiple threads to write data to your hard disk. And especially when you're handling bigger files or documents or whatever, then it makes sense to have multiples of that channel counts. And I would say a sweet spot is something between 2 and 8. And it also needs to be power of 2. So you could have one channel, 2, 4, 8, 16, and so on. And that provides you more threads for storing data. That will accelerate the storing capacity, I would say. To be honest, I never used more than 4. 4 is totally enough because EclipseStore itself is such an insane fast memory that is not needed more than 4. Because if you have to consider more channels means more data which is divided into pieces. And after that, when you search for something, you have to find it in the different channels and so on. Then yeah, use something. You have check it out. Feel free to test it and to see the results. Okay, so this is the setup. So I have books and authors in the same way than in the project before, but there is the controller, and we need to implement the controller methods here. So I've told you that we need to talk about those CRUD functionality. Okay, one moment. Okay, so here we go. So what we do here in the first get method is to create the data here. So that means the mock-up utils provides me authors and books, and I need to store them. And we already talked about this. This should be really straightforward. So we need to say db.root.getBooks.add all, I guess. And then we add all the books that are loaded. And last but not least, we need to store it in the same way we did it before. And I just want to, oh, not db.root. We need to get the storage manager.store. And guess what to store? Not the load mockup data. We need to store the reference holder. And that's why I use db.root.getBooks. That's the collection we want to store because it holds the references to all the books, and then we are good to go with that method. So that's all we need here. So creating stuff or inserting stuff works really straightforward in the way that I explained. Creating a single book, yeah, it's totally the same. We need, let me code this because that's easier. db.root.getBooks.add.book, and of course we need to store db.storagemanager.store. It's always the same. db.root.getBooks. That's all we need. Next step, list books. I mean, that's the easiest part, right? So just return all the books that we want to have. Easy task. A more advanced thing is let me find books that starts with an A, for example. So, and this is where the Java Streams API comes into play, and that's what I mentioned at the beginning. Most of you are pretty aware of the Streams API, and that's why I skipped the Streams tutorial a little bit. And yeah, let's start here. Return. What do we need to return? db.root, that's the entrance point to my object graph, getBooks. And that's the moment where the stream stuff begins. Give me that books, stream through. Let's choose filter. And then we want to have, let's use B for my book, b.getName dot starts with, and then we're using an A here, and that's exactly what we need. And then we say at the end to list. This is all we need when we want to search for a specific book or a range of books that starts with an A. Okay, let me just answer that question directly. There is one question. What happens if the serialized data is not binary compatible anymore because we removed a field? Interesting question. That relates, in fact, to the last topic for today, is what happened if data structure changed, and be sure we will take care about this. There are some rare cases that you need to do something, but at the end, you have to take care in the same way than it happens on a relational database, for example. But let me get into this a little bit later. Okay, so the Streams API got books with an A. And we need to clear something, of course. No? We need to delete some stuff. We need to handle this. And to delete something, you would say this is as easy as it could be, db.root.getBooks.clear. So that's all we need. And this is a basic Java method just to clear the list. And guess what? We need to store you see, it's always the same. db.root. Oops. You see, that's all you need. You clear something, you remove something, and then after that you have to store the reference holder. Nothing more to say. And but you need to be aware of if that book contains child entities. All these child entities are also gone. At that moment, when you delete a book, you will also delete all the underlying references, because they are all attached to that specific book. And when you delete this book, you will no longer be able to address that elements. And after that, after this is cleared, the garbage collection will remove these books from the RAM, and also all the sub elements and child objects and so on. This is I guess in the relational world it is named cascading or stuff like this, and it's the same way in EclipseStore. Clearing books. Update a book. That's also interesting because it's a case that we did not talk about. So let's say, let's load the first book. So let's say db.root.getBooks.stream. .find first and get. So let's choose it this way. Oh, come on. What is the shortcut for this? Can't remember the shortcut. Book. Let's do it this way. Okay, so now we want to change something, book set release, for example, and let's add a new release date. So then we use local date.now. And we have to store this in the same way than anything other. We change the book here. In that case, we change the book. And therefore, the book is the reference holder here. And that means we have to store the book itself. So storage manager.store book. And that's all we have to do. It's as easy as it could be. And now it's going to be, now it will be a little bit more interesting, because here is the point where there are multiple different possibilities to handle this. Let me just draw the code here, and let me explain you the situation. So the idea is we want to stream through the books that starts with an A. It's the same stream than before. And we want to do a for each here. And then we want to set a different price on every book that is found in the stream above here. And what we could do is now, let's say, okay, set the price. And after that, we're calling the method db storage manager.store. That could be a solution, right? So, sorry, we need to say B instead of book. So that will work, right? So nothing, anything from your side? Yes, of course it is. It is better to do this in bulk, and that's absolutely right. So instead of doing this, it makes more sense to create our own storer, and therefore it's we go to our storage manager, and our storage manager provides us two special storer method. There is a create eager storer and create lazy storer. Just to, I do not want to explain this in detail, but the lazy storer stores only the object which is handovered without the sub objects, right? So this is what the lazy storer does, and lazy storing is the default storing method. So whenever you call a store like here, it's always a lazy storer. Means it stores the object which is handover without the underlying sub objects. But this is only for updating stuff. So when we're creating a book on inserting or something, then all the child entities will be stored also with the lazy behavior. And the reason for that is this is best practice, because EclipseStore works like an appendant storage in the background. That means everything you work on. So let's say when we store it here, a book, for example, this book will be attached to the end of the storage. And there is a garbage collection, or there is a housekeeping process which removes the duplicate entries of the storage itself. And that's why the lazy storing is the default behavior. So And that's why we want to create a LazyStore here. And let's assign this, call it ls for LazyStore equals. So store, here we are. And now we could use that ls dot store, and B is the right one here. And that store method here is more a registration of that object within that store. It's not the store itself, but because at the end of that, we could call a ls.commit. And this is the moment where this situation here becomes more about a transaction behavior. Because based on that commit, this is the moment where the data is stored to your hard disk. And now feel free to use any try-catch behavior to handle your transactions. And also EclipseStore provides you a rollback mechanism, which is part of the advanced training. And then it becomes more transactional here at that place with that ls commit. So this is for sure one possibility to handle this. There will be a section within the advanced training, a more advanced explanation on how to do this. But for now, this is totally okay. You know the functionality of create your own LazyStore that helps you to handle those spike situations. Okay, any questions so far? So I hope I implemented everything like it should be, and let's give it a try. So let's start that project. I need the application class. Let me just update it. Okay, so run as, I need to check if there is a storage already be there. So, okay, makes sense. Run as Java application, up and running. I will do the course on my second screen. Let me just double check the controller. So I want to build book/create. Now you see EclipseStore is initialized. I get the message book successfully created. Let me move this that you can see it. And now when we call the books method, we should get back the 1,000 books that I have created. And here we are. And let's do this in a more advanced way. So let's create another and another and another and another. So let's create, let's say, I don't know, 20,000 books or so. I clicked a lot. So let me check if the data is stored. You see, it takes a little bit longer to load the data. I have no idea how many rows in the storage. And let me move my browser back here. Let's stop the application and start it again. And it gives you an idea how long does it take to load the data on cold state, I have to say. So, okay, this is the application up and running. And now, as I said, I have no idea how many books there are, but now books are loaded, so that's it. Now they are available, and every access, I think it's more the point that the browser have to handle that much data, but it's quite fast. As I said, I have no idea, maybe 30,000 or whatever, so I don't know. Okay, so this works, right? Any questions from your side? Did you try it out, the project? Any one of you? Does it work or any problems so far? At the LazyStore, of course. Here we are. So you have to create a LazyStore object. And then at this time, you will be able to register some elements here. And when you call commit, then it goes to your hard disk. Okay, by the way, there is one typo that needs to be removed. Okay, great. And there are two questions that I'd like to answer before we go on. The first one is, can EclipseStore interact with traditional databases, e.g. if we want to aggregate data sets which are stored both in EclipseStore and traditional databases? A quite good question, because that's exactly happened when we're talking about the usage of EclipseStore in combination with caching layer in between database. But yeah, it's a quite individual answer, because mostly when we use this on our customers project, we first need to know what type of database do we talk about. So is it an Oracle, Postgre, SQL Server, whatever? And then we're mostly using the embedded functionalities of these databases, kind of like data update triggers or something like that, to communicate with that caching layer. So, and most of the database are able to implement those update triggers, who are able to update via REST call, for example. This could be possible, but especially, for example, for PostgreSQL, PostgreSQL is able to implement such an update trigger within Java directly, and it updates. So it updates your cache on updating the database. So, but it always depends on your storage layer on your database to interact with such an, yeah, let's say caching layer, which is based on Micronaut or Micronaut or Spring or whatever. So just use the technologies they are actually on the market, and combine this. As I said, this is not a functionality that belongs directly into the storage engine of EclipseStore, because EclipseStore is good in things to store things and to be a storage handler, and it manages your RAM and it stores everything. It's not part of EclipseStore to communicate with your database, and because it always depends on what database it is, and we would need to add a lot of different implementations for different databases. So use the things that are actually on the market. So like update triggers on, and it also depends on your caching strategy. Do you want to have write through, for example, or invalidate your cache or whatever? It depends on the situation, but there are many possibilities to interact with your database. I hope that answers the question a little bit. Another question from Dan. This is a great question, I have to say, because it's also quite complicated to answer. You are right in one situation, that you never know when you update your RAM, and you are not sure if you updated the underlying storage. So, I mean, that is normally a topic I come to this on the advanced 2 training, or on the advanced training, when it comes to the exception handling. The situation is you need a proper exception handling. So that means, because EclipseStore itself is, because of its architecture, a quite robust solution. That means there is no I/O, or there is no network transaction or network communication in between. It's just your application and the underlying storage. And that's why that is a good question, is what could go wrong. So, but you are right, especially when we're using, for example, Docker or Kubernetes with some persistent volumes, it might be possible that this volume is detached or whatever, and then you will get an exception. And this is exactly the moment where it is important to have an exception handling in place, because at that moment, when you see something goes wrong at that storing method, I have to say, then it's time to shut down your storage, because then really something is wrong within your storage. And that is exactly that moment when you will not notice it at that moment, because you're storing or you're adding things to your RAM and you're working on the RAM at the same time, you will not notice that something goes wrong. And you will notice it after a new start, let's say 4 hours after, and then you see all the data is gone. So that means based on that, you should have a proper exception handling in place to prevent such situations. But to test this exactly, that's another step. I mean, if you forgot to call the store method, that's what should be tested, of course. If there is a real test, if the data is on the storage, I have to say yes, because there is a transaction file in the background, and you will be able to check that transaction file if the transaction actually worked. But I'm afraid there is a method to prove this, but I cannot answer this for now. So I have to ask my colleague. Maybe it makes sense then if you send me an email, I will send you back the answer, but I have to check this. But the question is more, I understand your question, but proper exception handling is for sure important. And how to test this, it's a good question. So please let me know this by mail, and I will do my best to answer. Okay. Another question from Bob. Any books on EclipseStore? You mean real books to read in, or documentation? Of course, I missed that to forward you this. This is the documentation, so feel free to check it out or to export via PDF or whatever. No, there's not as I remember. So there is no real books available for now. And not books, but documentation is available also for the data grid. Yes. You will find everything within. So when we go to the Eclipse data grid, so this is the application itself, so the cluster platform, and you will find on the home screen there is a getting started, and when you click there, you will see directly all the on-premises stuff and cluster stuff, data grid stuff, and so on. So there are two separated documentations. One is the normal one of EclipseStore, and the second one is the documentation regarding the data grid. Okay, so great questions so far. So let's move on. Next step, I want to go into the proper object model. We talked of some of that topics already, but I think it's never wrong to repeat something. So, proper data model. There is a lot of stuff to consider when we're talking about the data model, and especially when we're talking about a technology like EclipseStore, because it's not a technology like all the others. It's a totally different approach of handling data. It's not compared to relational databases. It's not really similar to a NoSQL solution, but even the NoSQL solutions are different, has its differences to each other. But all the NoSQL solutions or technologies compared to relational, all these solutions they all have its own model, and I think that's one of the big differences between EclipseStore and a relational database or even a NoSQL database. But it's different to think about. So there are questions: where are all my tables, for example? Do we need tables anymore, or should I create a list of all my objects and how to bind them together? Are there any primary keys or foreign key solution? Or should I use lists instead of sets? Or is there anything other than such lists? What about bidirectionals? Do we need bidirectionals on EclipseStore? what is lazy loading? We will come to that a little bit later. And I think most of the things you need to think about is what are my business needs? Because now with EclipseStore, you are able to create an object model that fits best to your business needs instead of creating an object model that fits best to your database because of Hibernate mapping and so on. And it's much more important to think about how much data do we have? Is it, we all always discussing about, or the discussions are all the time about, is I have 12 terabytes of data. Does the data fits into EclipseStore? And do I need such amount of RAM, or what amount, how many RAM do I need? The question is more to, do I really have to store 12 terabytes of data in an in-memory database? Does it make sense? Do we need that 12 terabyte data all the time in such a high performance? Or that 12 terabytes consists of the last 20 years of data of my company? Or is it just archive data? Or is it documents or files? And do we need to provide these files in high performance? That is a much better question. And then we have to say, okay, let's cut this data in half and store that archive data on a much cheaper storage, which doesn't need to be that fast at the end. And only a small amount of data needs to be provided within high speed. But let's come back to the data structure itself. Let's use an example to make it more clear. When we're talking about a book selling company, for example, with multiple bookstores and selling thousands of books a day, then our object structure would look like this. We have a company on top. Our company has an address, of course, and a company has multiple stores or multiple customers. Each customer has its own address or multiple ones. And then we have on the store level, we have the same. We have books there, orders, employees, and so on. And this is what our object model could look like. An interesting view on that is when we compare both sides now. When we have a look to the relational database, we see every object itself has its own table, right? So this is how a relational database works. We have a table for companies and books and authors and stores and so on. And these things are bound with foreign keys and primary keys. When we compare now the Hibernate model at the end, Hibernate, when the data is available in Java, it looks more like an object model, right? So that's what we call OR mapping in between. So when the data is loaded, then it will be mapped to an object relational model. But and this looks more familiar to an object graph than this side. In fact, when we compare these both things, EclipseStore takes the best things from both sides. That means we are using tables as in the same way that we use collections on the EclipseStore, but half the amount. So that's the point. That's an interesting point. Half the amount because, for example, book, for example, is or books here are divided by a store. So that means the store itself works kind of like of an index of books. That means if I want to find a specific book, I go through the company to the right store where I want to find it, and then I stream through the books. So there is it's not needed to stream through millions of books to find something. Mostly you will navigate along the object graph itself. And on the other side, we are using relations, fields, and validators, which are by default or by design part of the object graph in Java itself. So that means we do not need any foreign key or primary relations anymore because relations are naturally in the object graph itself available. So, and that's why that is what we use. So we're using powerful collections, list set maps also, or even gigamap for the basic structure, I have to say. You remember the first lists within the root object, maybe. In our case, maybe a list of stores or a gigamap of stores to handle such huge lists or collections. And then the underlying stuff is part of the object graph itself. So once we are in a specific store and we want to see some orders, then we have to go through the order, that's for sure. And I think let's pick all the advantages from both sides and combine them into your object model. And I think that's the point here. That is also a question from our customers, how to migrate data to EclipseStore. I always recommend, give it a try to use the basic created Hibernate object model and try to migrate this. So that means use the same classes that you are used with all the annotation, doesn't matter, and try to store it within EclipseStore, and you will see what works best for you. Is it necessary to have a special index or what? So, and with that knowledge, I want to go into a small example I prepared in the first project when it comes to the data model itself. So, 1 second. Okay, so as I already explained, we have a book here. So the question is how to store the books, the book itself. Well, we answered that question already. So we need one root object. So let's create a root one. So we could have a list here, a list of books, of course. So that's the easiest approach here. So let's say books. This is one way how to store it. Let me just add private list. Oh, sorry, book here. As I already explained, book or root could be a synthetical one or a business one. And then we have a list here. This list here of books is one possibility. It could also be a set, or it could, so let's do so. Or it also can be, could look like a hash set, for example. So this is also possible, or use a hash map, for example. Then we have string, like this, right? So, and this is books, new hash map, string, book. Yeah, books 2, whatever. Did I miss something? Yes, this one here. Okay, good so far. So this could also be a solution. When to use this one, for example? When does this make sense? So it makes sense in a lot of in a lot of situations, because finding a specific book based on its unique identifier, I have to say, because we do not need any primary keys anymore, because we could use something like this. So a book ID, right? So we could say integer, whatever, sorry, private integer ID as a primary key. But then it's necessary to count it up or to increase the number for every book. But this is a synthetical entry, and it makes much more sense to use a business related identifier like an ISBN, for example. And if you really need an ID, which is a technical one, then I would recommend to use something like private string. Oh, sorry, I have to. Sometimes now this looks better. So sometimes it makes sense using stuff like string and a UUID, for example, equals, and then we say UUID dot random dot to string, something like this. If you really need a technical identifier, I could recommend this one. But anyway, an ISBN or a business-related identifier makes more sense. So, and exactly this identifier could be part of your hash map here. or it could be that's here the string is a combination of some some often searched for things like an index based on the first 3 digits of the ISBN or the first 5 digits, just to decrease the amount or just to decrease like this one, having a list of books and with, let's say, here we have the first 3 digits of the ISBN, and then we have a list of books here. And this list of books could be on top, maybe lazy loaded. That means we only having this index in memory, and the book itself stays on the hard disk till that moment it is needed. So I would say there are many different possibilities. And on top of this, we provided that GigaMap also that handles all that lazy loading stuff automatically in the background with with indices you could create and define. But this is a topic for some more advanced trainings. Okay, so set or list is good to use, but hash set sometimes is better and much more recommended, I have to say. And I will come to this a little bit later when we talking about lazy loading. Okay, let me just check if there is some more interesting topic. Yes, there is one. So let's say we have a book here. Here, and we have a private author. So that's great, right? So author is part of the book. And now what happens if we delete the last book of a specific author? That's an issue, right? Because we will lose the information on that author, right? So because author is attached to book, when we delete the last book of this author, the author is gone. And sometimes it makes sense to have an additional list of authors, maybe in the root. So that means beside the author in the book, we need a second set of authors in the root object, right? Now you might say, okay, does that mean that we have doubled the amount of objects or double the amount of RAM if we look at this? What do you think? Where are the experts of Java objects? Yeah, they are just references. Sorry, what was the question? Okay, yeah, you are right. An author is just a reference to an object. So, and if we use the same author from here within the book, it won't doubles the amount of RAM. And we have a list of authors here for usages in combo boxes or whatever to provide a list of available authors or whatever. So that means that is the point where we're talking about bidirectionals and so on. Sometimes it is necessary to have that, but it's, in my opinion, it's much easier to handle. And you will see when you're working long time with EclipseStore and you have to come back to a relational database, it's horrible. So because it's so much more easier to handle those references, yeah, feel free to check this out. Okay. That brings me to the next topic. But before, I will try to answer your questions. So there is one question. Let me just scroll up. Okay, this should be answered. Are there any non-free paid features? The last I remember is the data grid, or let's say the GigaMap, but it's now released open source. So there is, as far as I know, no non-free features, except the data grid, of course. But yeah, that's only the fee for hosting stuff and so on, because it's a SaaS service. Except you are using the on-premise solution. And yeah, then it comes with support, of course, because it's not the easiest way to have such a real working replication in place on Kubernetes and so on. And sometimes it makes sense to have support here. Do you have experience with domain-driven design and EclipseStore? Therefore, I would need some more context on this, maybe. I mean, I know domain-driven design in a way, but I couldn't imagine a situation that doesn't works with that, because it's pure Java and feel free to use whatever you want. So I can't imagine something. Okay, so that's the point. Let's move on to the lazy loading section, and maybe one of the most interesting things for you. And I prepared a small presentation to get into this topic. Lazy loading. So we have to clarify, why do we need to store and load data a lazy way? What data should be stored? That's also a good question, and loaded lazily. There are some things you need to know regarding your decision making, I have to say. How to use lazy references, that's important. Best practices, of course. And how to release lazy data. This is also important to need. So if it's loaded, how to release it at the end. There are some projects we will talk about a little later, and we will also do testing at this, but let's get into it. So why lazy reference are important? Well, EclipseStore is an in-memory database framework. The name says in memory. That means that's the reason why we are that fast and that performant. But for some reason, you could not hold the whole data into the RAM. That means on the other side, for best performance, data needs to be in the RAM, but in some cases, it's not possible to hold all the data inside the RAM. And sometimes it's just unnecessary to hold all the data inside the RAM. That's all. That's for sure, because we do not need to have all the, let's say, Word documents or PDF documents every time or all the time in the RAM. So it's not necessary. So that means we need kind of like a mechanism to handle this. Let's have a look on the default behavior. So I already mentioned this. So we have, let's say, 100 million objects on your storage. And if you start up the storage, then you will have 100 million objects in your RAM. At that moment, if this is your use case and this is needed, that you have that data or that amount of objects in memory, then it's okay, do it. And by the way, do you know the biggest sized memory EC2 instance on AWS? How much memory you could have? Have an idea of that? I'm not really sure, but it's terabytes. I guess 12 terabytes of RAM is possible nowadays. So who cares about RAM? If you need that data in memory, have it in memory and keep it in memory. But thanks God, there are some lazy points that we could set within the object model. And it works exactly this way. And we could set, for example, the lazy point here. So let's say 100 million, whatever. Then we set the lazy point here. That means everything below that not here will stay on the hard disk, 6, 7, and 4. And that's an interesting, because the real power of lazy stuff comes with different lazy points on several different layers of your object graph. So that means when we load object number 1 or collection number 1, whatever, that means that the collection or object number 4 here stays on the hard disk as long as it is really needed and it's really loaded. And this is how it basically works. Lazy itself, it's a wrapper object, and it works kind of like of a proxy that knows, okay, whenever we call the get method, that layer, then we will get, or the data is loaded on in memory. So on startup, it looks like this. But there is always a situation you need to be aware of. You always have to consider if you the more concurrent user you have on your system, the more data will be loaded anyway. So I will give you an example. When we're talking about 1 terabyte storage, or let's say we have data 1 terabyte. So I'm pretty sure we will be able to run 1 terabyte data on a 4 gigabyte machine. When we're using lazy loading and stuff like this, no problem. But at that moment, people are starting to work on that engine. They will start to work or to load that data. And the more concurrent user you have, the more data is in memory. And this is the same situation on your current application server with relational databases and cache and so on. And that means you should really think about if it makes sense to have that data in a lazy way. Because when the first person comes up and loads the data, your strategy is gone. You know, it's always important to know, okay, what is the data that needs to be lazy loading? How often is it accessed by users and so on? Yeah, think about your business objects and your business needs. Okay, so the basic best practices I want to share with you. When to use lazy loading, I would recommend always on binary data. And this is straightforward, right? So when we talk about blobs, documents, images, I would always use them the lazy way or load them the lazy way. Always on huge collection. That's an interesting sentence. So with less frequented data, that's the important part here. When we're talking about logs, archive data, yeah, data which is not needed all the time. So then I would recommend to use it to load it the lazy way. Sometimes on collections with huge amount of sub-entities, that could also be interesting. But remember, I've told you that lazy points on different layers will handle this also. And yeah, basically whenever you want, and performance isn't that important in this part of data model, or if the amount of RAM is limited. But you always have to consider the more concurrent user you know will increase the data anyways. And this is how to use it. This is one example of using it in combination with an image, for example. So this is the blob situation or byte array. It's just lazy. It's called lazy and it's an own data type. Yeah, kind of like a data wrapper. And it is, so you could add everything here. You could be a list, hash map, whatever. Feel free to use that lazy at any time. And this is, by the way, the example here that makes a little bit more sense to me because that string gives us the possibility to search within that hash map to find the right byte that we want to load, and then we are able to load it. So to load an image, which is loaded the lazy way, we could use image.get to get the blob out of the lazy wrapper. Yeah, and as I said, hash maps are always great to use it within lazy and so on. I think that's okay. Huge collections. So that's also an interesting situation that works basically great. So we have a list of books, for example. It's lazy loaded, but what do you think? Is it a good solution here? Lazy and then a list of books. What happens if you want to stream through the list of books? Yes, we have to load it. So this makes sense. I mean, that's an okay approach, I would say, but you always have to consider when you want to stream through or search something, you always have to search the whole list or stream through the whole list, and then it needs to be loaded at that moment. Could be for, I would say, smaller amount of lists, this could be, that could make sense. And it's initialized this way: lazy.reference new array list of books. So this is the way how to initialize it. As I said, low, medium size collections, and that's okay. This, I would say, is the more advanced situation. I also shared this already with you in a project. So there's a hash map. We have our own string as an index, and then we have a lazy list of books that enables us to loading those books chunk-wise, I have to say. And this will decrease the, well, there is a more extended, let's say we have a string here and then a lazy book. So that means we have, for every book, we have a lazy reference. That could be really helpful if the book itself is a huge object, for example. Then it makes sense. If it's just an object with 4 or 5 fields, then it doesn't make sense, because the lazy reference itself is heavier than the book itself. That only makes sense if, yeah, if the book is a more heavyweight object. Okay, about indexing. How to release the data. So if data is, so by default, there is an automatically release of lazy loaded data. That means the first indicator is if an object stays untouched for around 30 minutes, then it will be cleaned automatically. And there is another step. If we're reaching 75% of memory usage, then the RAM is also cleaned. From time to time, there is, we call it housekeeping process that runs in the background. That process takes care, and you will be able to adjust this. So, but there is always the possibility to clean or to clear that the manual way. And you see this down here. So there is that lazy image dot clear method. So, and this clear ensures that this object is cleared from RAM. But be aware of, you will need the garbage collector to release the memory really. So I will show you what I mean a little bit later. There is also a possibility to adjust the default behavior, as I mentioned. So you could add some lazy reference manager and could set it to duration of 30 minutes and the memory quota here. So this is up to you to define this. Just play around a little bit. You will see the result if this works for you. Sometimes it makes sense to adjust this a little bit to make it suitable for your use case. Okay, let me just go into your questions. Such a lot of things here. It's okay to have more than one storage manager in the same app. Okay. Is it okay to have more than one storage manager in the same app? It is okay. There is nothing that speaks against this. Maybe it makes sense when we're talking about a tenant-based system, for example, when we have multi-tenancy, for example, then it could make sense to have multiple storage managers. It's on you. Mostly we do this such a thing when we doing this internally. So that means we have one root object with multiple companies, and each company works as a tenant. So it's not it's not divided on the technical layer. I would say it's more divided on the object layer, but it's on you. It's possible to have multiple ones. No problem. Then we have Hetzner will give you 192 gigabytes of RAM. Yeah, but this is far too low. when we're talking about max size of AWS, I'm pretty sure we are in terabytes. Max RAM. Let me just Google this for you. Max RAM EC2. 768 gigabytes. 24 terabytes. The maximum amount of RAM available on a single site AWS EC2 instance is currently 24 terabytes. So this is the maximum you could get. It's expensive, but if you need it, you could have it. Okay, so a lot of stuff. Yeah, let's jump into that. Maybe that answers your question that follows here. I prepared a project for you, which is called LazyDemo. Let me share this. And let's do a little bit research now. Just a moment. Lazy. Here we are. Okay, this is the link to the repository, and this leads you to that project here, LazyDemo. The LazyDemo consists of, let me just check, many different branches. Let's start on the master branch. So I think we are already there. So let's have a look into the data root where most of the lazy part is. So you see we have a list of persons here, and I prepared let's say people JSON, and this JSON has 1,000 peoples in it. And you see that when we scroll further right, so we see there is a big sized string in it on each entry. So just to have a little bit, heavyweight data, I have to say. And let's see what happened when we store this. And based on that, I have to need my visual VM to do a little bit on research on that. Okay, data is not loaded lazily. It's just a list of persons and a list of people, I have to say. And this is the application. Right click, run as. Oh, I just have to double check if there is a storage already available. And there is. I need to delete it. Okay, so let's start up. One moment, just to be sure. Build it. Okay, let's move on. Okay, so application is started up. And now you need to have a short look to the controller class just to, and now this is the create person method. And we see here there is an int stream running. And every time we call that method, create persons, it creates 200 of that JSON mockup data here. So that means when we call this, we will have 200,000 persons inside the storage. So let's give it a try. But before, we need to set up the visual VM. And we need to see what's going on the RAM side here, just to give you an idea, what are we talking about. Okay, so I'm ready. Let's do so. Localhost 8080, and what was it? Create persons create. Persons/create. Okay, so application starts up. So you see memory consumption, CPU is working not that heavy, but memory, okay, so it's there. So you see this is the result, 200,000 in total people created or person created 200,000, and we have a memory consumption of around 1.5 gigabyte. So when we perform garbage collection, I'm pretty sure we will go a little bit slower to around 1,250 megabytes. An interesting information is also how big is that in compared to the storage itself. So let's check. Let's do a refresh here. And let's go into the data. And let me just show in System Explorer. Just a second here. So this is the data here. And now let's have a look at the properties. And you see we are around, so we need less memory than the data on the hard disk itself. So we are on 1.53 gigabytes. And yeah, I would say it's 1 by 1. So let's say it like this. And I think that's great. That's an okay value. Okay, but this is how it works non-lazily. Let me call this application again, and you see this is the second start of it. And you will notice that every call makes it a little bit slower because, as I said, it's an appending, attaching storage. But now you see we have 400,000 elements in the database, and the memory consumption, I would say it's okay. It's not that much. Okay, this is the non-lazy approach. So let's we do not longer need this. Let's stop this, and let's go to the next situation, the next branch, and let's see how this works when we changing it to lazy. So it looks like this. So we have a list. Now we have a lazy list of persons here, and it's initialized in the same way that we have seen this in the presentation. Lazy reference and so on. So okay, let's start. So application run as Java application. We should not forget to okay, we are calling the same person create method. I will do that on my second screen. And this will not be a surprise. It works the same way because we have to store the data. So now memory is there. So the same amount, I would say, nothing special. But the differences here is when we now restart the application. So when we initialize the storage, and that's the reason why I added this method here in it, just to initialize the storage. That means the data should stay on the hard disk. So because it's not loaded anymore. So, and therefore, let me just start this. And now I'm calling that init method. So let's say localhost 8080 init. Persons init. Persons/init. You see, EclipseStore is initialized, and when we now have a look on the memory consumption here, we see that the database itself stays on 200 megabytes. So because at that moment data is not loaded because it's lazily handled, but at that moment we are calling the get persons here, then we are loading the whole list of persons to stream through. So should be this one. And now you see data goes up again. So because data needs to be loaded. And this is the result you see here. And at the end, we are on the same amount of memory consumption, a little bit higher, because now we need to calculate the lazy objects also. or the lazy proxy objects. And that is the differences between, these are the amount of lazy elements, wrapper objects in between. Okay, I think you get the idea behind. So you get an idea of memory consumption and how this works and how the lazy stuff works. There is one little example I want to go through. It's also in the DB class. This one. So this is, I have to do it this way. So this is the lazy reference manager. So this is the possibility to adjust the lazy handling. So to release some objects, and let's give it a try. So let's save this and this. A lot of stuff is going on my computer now. So we do not need this anymore. Okay, so let's start. Okay, here we are. So let's create some data. And now that is the interesting moment. So this is the monitoring. So I will start it on my second screen. So person/create was the right. So now we should see that the data goes up. So because data needs to be loaded, even if it's lazily loaded. But we should see now, after 1 minute, we should see a drastic reduction of memory consumption now. So let's wait. So we started to add the data at 2017:45. And after 1 minute, we should see that the data is gone because of the lazy clearance, 1 minute. So that's a good opportunity for me to drink something. Close. Okay, so as I said, it's always important to wait for the garbage collection. So that's why I want to perform garbage collection for you. And this is exactly what we expected to happen here, that the data is released automatically by the lazy reference clearance. Okay, last but not least, a third example and the last branch for that lazy loading topic. It's an interesting approach of a full lazy map. So let me just check this out. So let's have a look into the structure here. Let me just, no, not DB. This is not necessary. So data root is interesting. So you see that's an interesting approach here. So we see that every person here is lazily loaded, and we have an index here based on. Let me just check. There is, you see that persons.put p.get mail. It's a combination of mail, a random UUID, and that is the index to find a specific person. So so when you want to search for a person by mail, whatever, you could use this. And then we have the lazy, the person itself wrapped in a lazy element. And this is a great solution for handling this. So let me just double check what is the lazy clearance. It's 1 minute, that's okay. And I need to double check. There's a get person. Yeah, there is another endpoint finding a specific person by mail. So that's the interesting one. That is needed. Okay, let's start up this. Now what we will see is an increased amount of memory, of course, because of the amount of lazy references on that. So I create some persons or peoples. Now the memory consumption should be a little bit higher than usually. Okay, so you see that we are around on 1750 megabytes. Could do a garbage collection here to decrease it a little bit more. So yeah, we are not that much higher than expected. Okay, we have to wait for 1 minute until the garbage collection has cleared the most references. And then we could use our endpoint to search for a specific person. But therefore, I have just to check for an email. Let's use this one. And then I need to check. Okay, /person/mail. Makes sense. So let's try to garbage collect this. Oh, you're not. It cleans step by step. Yeah, it goes down more and more. But I think it's not that important. So we had to wait a little bit longer because the lazy clearance needs more time within that structure. But it doesn't matter. Let's do this mail, and then we need to add it this way, right? Is that how it works? Or it's a query value, so I have to do it with a question mark, right? No, not with a this way, right? No. Not found. Let's do this. /persons/mail. I missed something. Give me just a second. Okay. Yeah. Mail / this one. No. Mail. Another query value. Mail. Something is wrong. Please tell me if I missed something. Could not found. Let me just test this. When you say persons, we should get all of them. Okay, that's. And I have to add the mail itself. Get persons per stream filter K to lower contains mail to lowercase. Yeah, this works, but person controlled null pointer. Yeah, I don't know why, but a query value needs to be a question mark, right? No, something. Just a second. So, um, is it called mail? Yeah, maybe. Then I have to do it like this. Yeah. Person's mail. That is not what I expected. So I have to check it out. What I have to investigate this. What is wrong? So what we should expect is, you see, memory is down here. I could not say why it does not work. I mean, that is the wrong way. We do not need this anymore. But sorry, I need another browser. So this is what I tried to do. But the question is why it brings so many elements back when I call this. Could not find the reason for that. So when we call for this, it takes a little bit to search through. I'm getting a result. And the memory consumption stays low. Maybe it's something weird is going on, but I think the result is okay. So we're getting a lot of stuff back without loading. So we search through the hash map and we are getting a result. I don't know if this is the real result or why it is finding that much. But anyway, I think the message is okay, and that gives you an idea what's possible um, on the basic Java layer. And when we're now talking about GigaMap, for example, that's a more extended indexed collection. It's not part of the training today, but feel free to check it out and see. And this is working even better than what I shared with you. But this shows you what is possible on the basic layer of Java. And I think that's okay. That's okay. We do not need this anymore. Okay, so this is what lazy loading means and what the lazy loading topic is. Any questions from your side now? Yeah, thank you. Yeah, a person mail equals email. I tried this, but I don't know. Yeah, maybe I have to double check this later. When does it make sense to start sharding your EclipseStore dataset? Oh, I don't know. So the question is, yeah, when we're talking about sharding, sharding could be at so many layers. I have to say, when we have a data provider for, let's say, employees, one for products, one for this is also sharding on another level. Let's say on the data structure level. 1 billion entities stored in a single object graph. The question is how this could be sharded in a good way, because there is no sharding solution available from our side. Now at the moment, we are working on a solution like this, but yeah, maybe give me just a second that I could read it to the end. Or can I copy that amount data easily provided enough RAM and storage? Yeah, so from my point of view, when we're talking about sharding, I would say it's okay to stay as long as you can on the vertical scaling approach, because that prevents you from a huge complexity of infrastructure and so on. And it's by far more expensive than in my opinion, it's more important to think about replication first to cover data traffic and have replication and, let's say, failover scenario and so on. That's more important than sharding, because as I said, RAM and CPU is cheap in my opinion, yeah, and it makes more sense. But that's the question itself. It's yeah, it's hard to say, because it depends on your use case, on your data structure, on so many different things. I would say it's hard to say if there are any best practices. It depends on so many so many data things and the amount of users and data and so on. Yeah. Hope that answers this a little. Maybe we could clarify this also within a single meeting. Feel free to let me know via mail, then maybe we could answer this. Can you speak about security, comparing EclipseStore security with that of traditional databases? Of course I can. Yeah, security. So when we're talking about SQL injection or something like that, then this is not possible on EclipseStore. So there is no fear of that anymore. The data itself in the background is a binary format. It's a non-readable binary format, so it's not a readable one. That means even if an attacker reaches your server, the attacker will not be able to recreate the data without the data structure. So it's a binary format, and it needs your data structure to, let's say, to reload it and to see what's going on in that binary blob, I have to say. So that means data is in a non-readable format. If you want to encrypt the data, then feel free to use the normal hard disk encryption that is provided by AWS, and it's standardized. I would not recommend to do your own encryption. That doesn't make really sense, because that leads to non-readable stuff in your database, so that will hinder you from searching and so on. So I will also always recommend to have using encryption provided by your service provider, or using something else encryption format on your hard disk. Yeah, what else could I say regarding security? Yeah, I think that's okay. So if there are other questions, let me know. Okay, there are two more topics I want to go through. So smaller topics, but also interesting ones. One is the legacy type mapping. I want to talk about this, and therefore I brought another project. Let me just share this with you. So that's more on what happened if my data structure changed. So legacy type mapping. Here we are. Here is the project itself. So feel free to check it out. This project also consists of multiple branches, and I want to start on master branch. So just to give you an idea what we are talking about. I also prepared a small presentation, and I want to get into this. LegacyTypeMapping. Just to give you the theoretical knowledge of how it is handled within EclipseStore. Yeah, we will jump over that topic stuff. That is an important part. How does EclipseStore handles data types? When we have a look into a storage of EclipseStore, and we could jump into this. So where's my IDE? Here it is. So let's jump into the storage here. We should see refresh data channel. Here, that is that persistence type dictionary. And this dictionary is a readable format, I have to say. And it is a collection of all the different data types that could be stored or that at the end are stored within your storage. So that means when we scroll down a little bit further, we see here is, for example, that person entity, right? So this is what we stored. So every object that is built by you is listed here with a specific object type ID. So that's important. That's a type ID. And that brings me to the point of the presentation here. So this is exactly what we see here. So each type dictionary consists of all the types you have, and this is the full path name of the Java type. So when we now change something in that type, then a second type will be created. Like this, you see, there is one customer which has the persistence, the type ID 66, or 1,000,066. And when we create another one, so let's say a new one with ID, and you see we changed or we added the IP address here. This is the change that happens here. And then a new type exists at that moment. So at startup of the storage, the engine noticed that there is a change within the Java file and it creates another object. And that leads to the situation that multiple different versions of that objects starts to exist in the storage, because at that moment you touch an old object, it will automatically transfer to the new type. So that means during the time, EclipseStore handles those versions automatically in the background, and you don't have to take care about this. So this is handled automatically in the background. The question is, how does EclipseStore notice what has changed and what happens then? Well, the point is there is a heuristic in the background. So let's say EclipseStore guesses the changes that happens. And this, for example, is one example of the capabilities of EclipseStore, how to guess it or how to measure it, what happens. So it noticed the changes based on the position in the Java class, the name, the data type, and some other elements, what happens. So it knows automatically that name must be transferred to first name, or moved. Let's say it's moved to the upper part, and at the same time, last name is renamed to name. Age is moved, and there is a new one. These are things that EclipseStore is able to handle automatically. If you don't want that automatic mapping, there is also an explicit mapping also available. So then it's on you to tell EclipseStore how to handle that change explicitly. But to be honest, I'm always using this. And if you do the changes step by step, not all at once, so EclipseStore handled that changes perfectly. And then the only question stays, what happens with real changes? So when we're talking about data type transferring, let's say from string to integer or from integer to string or whatever, the real big issues, then I have to say it works in the same way than on any other database. You need a piece of code somewhere to handle that transition from one to another. And there are multiple options. There is the possibility that you can add a specific type of code and hand it over that code, that script, to EclipseStore, and then it handles that code to transfer old objects to new ones. That's one possibility. Or you use your own data, your own classes like get and set method to transfer one value to another. It's totally on you. I personally don't like this approach because that means that this code stays forever within your project. That's why it's on you. I personally prefer to create a new field with a name that sounds the same. Then I start up the storage, I convert all the data, and then I remove the old ones. So that's what we normally do, but that is totally on you. Everything is possible, I have to say. But more important is that most of the stuff is handled automatically, and this is what we will see a little bit later. So let me jump into an example now. So there is LegacyTypeMapping. That's the project. So we are on the master branch, and let me delete the old storage. So no storage is there. There is one domain object. It's an author, and it consists of male, first name, and last name. So let's just start this application here. Yes. So see that? Oh, I forgot that. Do that even update build stuff here. Okay. Another try. Looks better. So I need to initialize the storage. I will do this on the second screen. Localhost, and need to know the controller itself. Authors create. Okay, so let's say 8080 authors/create. Okay, see, database starts up. That's okay. And now we should see when we now calling get method. Yeah, this is the structure. Here you see that's the result. There is only one author in it, and the structure is male, first name, last name. Okay, so that's it. So let's stop the application, and now let's switch to the new branch. So say right, team, switch to changes stage 1. So let's have a look. So, and now you should see the changes here. So it's no longer only male, it's male author, and first name stays first name, and last name is changed to, or name is changed to last name. So when we now start up the application again, and we call the same method than before, now EclipseStore suggested you that exact same what I showed you before. So it says, based on the heuristic, there is a chance of 70% that the author hash male is, or the male field of the author class. That's what it says here. There's a chance of 70% that this is changed to male author, and it stays the same, I have to say. So there is 100% the same, and we have last name change here. And then it asks you, do you want to do the mapping? And I would say yes and confirm that. And right in that moment, the conversion happens in the background, and you see this is the result, the new result that we get from the storage. And you see male author, and you see the changed field. So this topic is quite an important one, and therefore it's handled in a big section of our documentation, which is called legacy type mapping. And there is a lot to know about this topic, and it's all explained here with all the corner cases or edge cases, I have to say. There is the complete explicit mapping part here. And you see this is, for example, that is the refactoring CSV file for providing such as explicit mapping things. As I said, a lot of stuff is going on here. Feel free to check it out. I have to say, for a fundamental training, that's totally enough that we looked into here. And yeah, last but not least, there is one thing that I want to share with you, and yeah, just to do this, I'm not able doing this right now. There is only 15 minutes left. Maybe we could give it a try. It's the UI that shows you the content of your storage. So, and I always have to check the where is storage? Yeah, here we are. So REST interface. So I hope that was okay for you. That legacy type mapping. Any questions so far? Let me just check. More than one storage manager. RAM expensive. Okay, no more questions. Great. Okay, so I prepared a project, of course, as I always do. So it's called Client UI. So we clean up that a little bit. So to close this. Okay. So Client UI, and it's a normal based Micronaut application. The only special thing here is on the DB class here, we added this line of code here. So we started the storage REST service, and you have to hand over the storage manager, so the embedded storage manager here, and you start that service. And the very first important information is this service is only for development purposes. This is not made for production work, and it's only made for the application to access your storage, to see what's going on. And this is what is described here. So you have to set up that REST service. So Spark. So you need an additional dependency, of course. And then we see it here. These are the 2 lines of code we talked about. Okay, so nothing more is needed. And with that, when at that moment we start up that service, we could go to the client UI. And the client UI is here, a download link. And I'm not sure if I'm able to use it because it's based on the 3.0 version, but let's do so. Let's download the client UI, and we should be able to start up that client UI with that line of code here. So just a second. That's not always the easiest part here. So this. So here's my downloads folder. Here we are. Oh, let me just start this. Oh, need to copy that again. Oh, no. Hmm. Hmm. One moment. So data user. now we are talking. So, okay, so, okay, and now I need to copy this and so yeah. This should do the trick. Yeah, looks good so far. So I started that downloaded file, and when I now open my browser, I should be able to. So what is the? So let's choose this one. Okay, so and now this is the application I started up, and now I need to use the URL here. And yeah, it's important that the application is started up. So it's not, right? So let's do so. Start up the application. And another important point is EclipseStore must be initialized. So it's important to call localhost or any controller here. Let's say books, create, whatever, books/create. Localhost 8081. That makes sense. Okay, no worry. I will summarize that for you to make it more clear. Client UI data is already there. So, okay. Okay, looks good. So EclipseStore is up and running now. And now we should be able to connect to the application. We need to find, yeah, here we are. So, oh, what's happened here? Is the root? No, we are right. So this is the UI that shows you the structure within the storage. And you see this is the root object. And it shows you also the object type ID here. Or the object ID, sorry, not type ID, object ID. And you see these are the books that I created. And you see the view on the data is in fact different to a normal database, of course, because this is a read-only screen. This is only, yeah, let's say it's a kind of like a helper for you to make it easier to, and more convenient to start with EclipseStore. That enables you to see what's going on in the storage itself, and if there are you see there is a release date, it's an own object, it's a local date, and you will be able to go down the author, for example, and you see on an object-based view the visibility of your object, and that helps you to see what's going on. From my point of view, I no longer use this anymore because I like it to directly work on my object graph, and I know what fields do I have and what elements do I have in my storage. And it's much more easier for me to just create my own REST interfaces, and that these interfaces returns the data for me, and that's enough for me to see what's going on. Then I use Postman to check if the data is fully there, and that's okay for me for development. But it might be easier for using this at the beginning to see what's going on, to getting an idea of the data within your storage, I have to say. Okay, just to summarize this a little bit. The first basic thing you need to do is to enable the storage service within your DB class and to call the service.start method. Then you need to download the application which provides the UI at the end, and you need to start it. So it's all the whole description of that process is in the documentation, but so here we are. So it's described here. And REST interface client UI. So you need to download that link here, and that enables you. This is the code to start the downloaded part, and then you need to choose store minus data. This is the connection to your storage, but this is also customizable. So that's on you to define this, but normally by default, this is the name, and then it provides you that overview of the data. There is additional information. Also statistics to see how much files are in there, the data size, how many channels. You will see how big is each channel, how many files does each channel have, and so on. And we are still on that to improve that UI, but yeah, it always needs a little bit. I think that's it. So let me jump to the very first presentation. Okay, so there are some questions. Let me handle these questions first. So I assume it's possibly multiple storage venture, right? I think we talked about this. I agree. Yeah, when it does sense to make sense. Sharding, we have this. Okay. Let's go through the planned topic for today. So we had that introduction by Marcus. Then we created a quick, small demo just to give you an idea how it works. Then we went more extended by the step-by-step configuration. Another use case of creating your own data provider with Micronaut. We talked about CRUD operation and lazy storer versus eager storer. Then we talked a little bit about data model and handling data. We skipped the queries. Yeah, obvious, we are right in time, so no more, but I'm sure every one of you is aware of Java streams. The usage of lazy loading, that was a little bit research on that to give you an idea how is the memory consumption, what we talk about. Then we talked about the client UI, and last but not least, the legacy type mapping. Okay, so from my side, I'm done, I have to say. So everything that I planned for today is transferred. I hope it was an interesting fundamental training for you. It was not that boring, and I hope you enjoyed it. I'm not sure when the next upcoming training is, I guess after holiday and so on, after summer. Feel free to join the next advanced training. And so far, keep on track with your certificate. Think about to register with the same email, then assigned to the training. Yes. So that's all from my side. Have a nice week and enjoy EclipseStore. Try it out. Let me know if there are some issues. Yeah, thank you for attend. Bye-bye.
Thank you, Ciao.
Thank you.
Bye.
Bye.
Yes, Anton, as I said, there will be an upcoming training. So let me just check. I could check this for you for a short moment. So, videos, training. Yes, here we are. So next upcoming training is on September 18th, 2025, same time. It's the advanced one. And this is also the training where all the data replication, data grid things comes into play. So yeah, feel free to join.